Today we're going to be talking about limiting reagents, reactants, and calculations in stoichiometry for day 4. We're going to identify limiting and excess reactants. We're going to use stoichiometric calculations to support the identification of limiting and excess reactants. So limiting reactant calculations generally are called LR, is the reactant which runs out first and limits the amount of product that can be made. So think of, for example, like if I have a hamburger, I want to figure out which ingredient or what ingredient will run out first before I can build it. So it could be the lettuce, it could be the patty, it could be any of those, but generally only one of them is going to be made. There's going to be two mass-to-mass calculations that we're going to be using. And the LR is called the only one that yields the smaller amount. So whenever you produce your product, you're going to be producing a smaller amount of that, and that generally is going to be called your limiting reactant. So let's talk about a real world example. Let's make some cupcakes. So if you want to make some cupcakes, you're going to have to use a couple of things. Eggs, eggs, and oil to make a pan of cupcakes. And generally you're going to have one mix, a couple of eggs, maybe 3, some oil, and then one pan of cupcakes. If you take a look at these ingredients, one of them is going to be determine the amount of cupcakes that you're going to form. So let's say you have 3 mixes. 15 eggs, and 8 tablespoons of oil. How many pans can you make? So based off of this ingredients, you need to figure out the amount of cupcakes that are going to be made from the ingredients that you have. So in this example, if I have 3 mixes, well, I know that in one mix, you're going to be making 1 pan because it's 1 mix per pan. For 15 eggs, I know there's 3 of them, so I'll be making 3 eggs to every 1 pan. So I'll be making a total of 5 pans, and 8 tablespoons will equal to 2 tablespoons to 1 pan. So we use the coefficient there. And our answer here would be 4 pans. So the question is, which one is it? Well, the one we're going to pick is the least amount of pans that we make, which is 3. So mixes are the limiting reactant because they are used up first. So if you take a look at the ratio, it's always going to be the one that produces the least number of product. Okay, so time to relate this back to chemistry. So let's go over to a question for potassium. 17.1 grams of potassium reacts with 14.3 grams of fluorine, while the reactant is a limiting reactant. And what mass of potassium fluoride can theoretically be produced? So the word theoretically means if I were to do this in a calculated way, what would it look like? So our first thing is we're going to write our word equation of potassium and fluorine gives us potassium fluoride. And we're going to write 2K plus F2 gives you 2KF. And we're going to go ahead and write down 17.1 grams of potassium and 14.3 grams of fluorine to make a certain amount of theoretical potassium. So the question is, which one do we use? So in this example, we're going to try to go gram to gram to figure out the potassium to potassium fluoride. And we're going to do a gram to gram from fluorine to potassium fluoride. So we're going to take 17.1 grams of potassium, and we are going to put grams of KF. And so in this example, we're going to go 17.1 grams of K times 1 mole of K divided by 39.10 grams of K. So in this example, we're going to have a situation where we're going to multiply these out, and we're going to take the moles of 2 to 2. And we're going to use 2 moles of 2KF to 2 moles of K to make 1 potassium, and we're going to add it to 58.10. So this answer here is going to depend on the molar mass of potassium, which is going to be 25.4 grams of potassium fluoride. So now what we're going to do is we're going to take the next one, which is 14.3, and we're going to take pretty much 1 over 38 grams of fluorine, and we're going to take a look at the number of moles. So it's going to be 1 mole of fluorine to every 2 moles of KF, which pretty much means it's the ratio. And we're going to take the molar mass, which is 58.10, and then we're going to get 43.7. So in this example, we're going to pick the one what's the limiting. So our limiting reagent is going to be 25.4 grams of potassium fluoride. Okay, so that's basically going to be potassium is the limiting reactant. because 25.4 grams of potassium fluoride can be produced. Okay, so if you have any questions, let's go ahead and get started for worksheet 4.